Okay, people, we are going to review today, how we determine the equation of a linear relationship from either a set of data points or from a graph. This is a very easy one for us to start off with, but just to get the basics down. First of all, making a data table, a table of values, is actually a very helpful way to do these. So all you do is just make an X and a Y column and write out a number of values. Now you really don't only technically need two, but we do want to make sure that these things are linear. Obviously we can see that it is. So I'm going to put down 5, but again you really only need 2. Okay, but anyways, here we go. For X and Y, so for X the first point there is at 1, and then at 2, and then at 3, 4, and 5. And then the Y values start out at 2, and then go down to 4, and continue on like that. So I think it's pretty easy to see here what the relationship is. Let's just make a third column here. And if I were to take the X column and multiply everything by 2, so 2 times 1 is 2, 2 times 2 is 4, and we see that that relationship then is quite easily described as simply the Y column is just 2 times the X column. So that's my equation. Y is simply 2 times X. So something like that's very easy, but let's look at something a bit more challenging, and maybe this should ring some bells from grade 9. Okay, so this is another linear relationship, obviously, and let's make a little X and Y table here for this particular graph, and it should look something like that. Okay, well, this one's a little harder to see, okay? But if you sort of look at the change that's going on here is a consistent change. That's what linear means, a consistent change. From here to here, this is going up by 3. And from here to here as well, this is going up by 3. Versus over here, this is going up by 1, and this is going up by 1. Okay? And so the change that's going on then is for every increase of 3, there's an increase 3 in X, there's an increase of 1 in Y. But we typically like to put it in, we talk about slope being in units of rise over run, so we're going to put the rise, which is 1 for every run of 3. Okay, so that's the slope of our relationship. So now what we're going to do is we're going to make a third column like we did before, and just simply multiply everything in the X column by a third. Okay, and what we get is 1/3, 1 and the third, and 2 and 1/3. And what is a bit challenging to see with this particular example I've given, because I've chosen a really crappy example, is that these numbers are all the same distance away from the Y column. In other words, if you look at 1/3, to go from 1/3 to 3, I simply add 2 and 2/3, right? So 2 and 2/3 plus 1/3 is 3. 2 and 2/3 plus 1 and 1/3 is 4. 2 and 2/3 plus 2 and 1/3 is 5. Yeah, so 2 and 2/3 and 2 and 1/3 is equal to 5. And so all I have to do then is take my 1/3 times x and then add 2 and 2/3, which is really, sorry, 2 and 2/3, the way I had it written there. Anyways, it's really 8 over 3, same thing. So then I can write my equation that is y is equal to 1/3 x plus 2 and 2/3 or plus 8 over 3, same thing. And that equation relates them all. And if you don't believe me, go ahead, if you plug in 4 or 7 or whatever into for x, you'll get the appropriate value for y. It works every time. Okay, well, let's try another example that's a bit more straightforward. Okay, so here's one here. Let's go ahead and make a set of a table of values here for this particular relationship. So this is one point there is 2, 4. You always put the x value first. There's 4, 7, and 6, 10. Okay? So let's look at that change again like we did before. So in other words, this is going up by 2. This is going up by 2 as well. This goes up by 3. This goes up by 3. So it's, whoops, by 3. So it's the same relationship for both of them. It's up 3 over 2, or 3 over 2. So let's make a third column then. which is going to be 3 over 2 times x. Well, 3 over 2 times 2 is just 3. 3 over 2 times 4, well, 3 over 3, that'd be 12 over 2, which is 6. And then 18 over 2 is 9. So 3, 6, 9, when you multiply 2, 4, and 6 by 3 over 2. And you'll notice these are all just 1 away from the number that we want. So I just have to add 1 to each of those, and I would get my number. So the equation then is y equals 3 over 2x plus 1. Okay? So hopefully that's a bit of a reminder, and you sort of see how some of those work. Let me kind of give you 2 more to kind of go over here real quickly. Okay, well this one kind of extends into the negative side of our XY axis, but nothing really changes. Same thing. Why don't you pause the video, make a table of values, and compare it to mine. So it should look something like that. And let's again look at the relationship, the changing values here. And at first glance, they look different, okay? Because it goes up by 10 while 1 goes up by 4. And then for the second set of numbers, x goes up by 5 while y goes up by 2. But if you do the same ratio, that is the rise over the run, so 4 over 10 or 2 over 5, they equal the same thing, 2 over 5. So that's what we're going to multiply our x column by to make our third column. And so when you do that, 2 over 5 times negative 5 is going to be negative 2. And 2 over 5 times 5 is just 2. And 2 over 5 times 10, well, that's going to be 20 divided by 5. So that's going to be 4. Okay? And so looking at those numbers, those are all the same distance away from the y values. In other words, if I take negative 2 and subtract 3, I get 5. If I take 2, subtract 3, I get negative 1. 4 subtract 3 is 1. So I'm subtracting 3 here. So there's my equation. It's y equals 2 over 5 times x minus 3. Okay? So that is what you have to be able to do. I'm going to give you one more as an example to do for homework, and we'll go over it tomorrow in class. Okay, so here's one for you, and I've listed all the data points for you, so all you need to do is make up a table of values and see how x and y are changing, multiply and add or subtract as appropriate, and we'll go over that one tomorrow. Okay, see you then.